Everything Tesla has developed for its vehicles, from the batteries and power electronics to the advanced motors, transmissions, software, and even the AI computer, can be directly applied to a humanoid robot. After all, the biggest difference is that instead of wheels, this robot has arms and legs. Tesla recently announced that if all goes according to plan, the Optimus Gen 3X, expected to arrive in 2025, will be IP67 certified. This means it will be completely dust-proof and can be submerged in water for up to a minute without damage. Now imagine a robot designed to do much more than just operate indoors. It will be capable of handling real-world challenges. In today's episode, we'll explore 5 reasons why Elon Musk believes the Tesla Optimus will become the industry standard for humanoid robots by 2025. And stay tuned, because the last reason will surprise you as much as it surprised us. Optimus' progress has been impressive. At first, the idea seemed like just a futuristic vision, represented by a person dressed as a robot. But year after year, the progress has been remarkable. Musk has repeatedly highlighted that Optimus will be able to perform a wide range of tasks, surpassing the 1,000 distinct activities mark. And with constant software updates, this number could easily jump to 5,000 or even 10,000. The big key to this versatility lies in its ultra-modern robotic hands, developed to rival human dexterity. While a human hand can perform about 100 distinct movements, Optimus hands have already been designed to perform at least 60 of them. In the past, a humanoid robot performing everyday tasks seemed like something out of science fiction. After all, who would believe that a machine could replace human labor with precision and agility? But Elon Musk has already demonstrated that Optimus can fold clothes, water plants, handle fragile objects such as eggs and batteries, and even operate a computer. What's more, Optimus can squat, jump, and move around in a surprisingly natural way in offices and other environments. Now think about the practical applications. In a clothing store, Optimus could fold and pack thousands of garments per day, eliminating the need for employees to perform this repetitive task. In the field, instead of complex irrigation systems, farms could use robots to water crops. And imagine Optimus making breakfast, collecting eggs, and assembling sandwiches for the kids every morning. What once seemed impossible is becoming increasingly real thanks to unprecedented technological advances. To make all of this possible, Optimus hands are one of the most critical aspects of the project and are receiving special attention from the Tesla team. Creating a robot that truly mimics human functionality is a huge challenge. That's why the new version of the arms now has 22 degrees of freedom, twice as many as the previous generation. Its hands are highly articulated and can move continuously, mimicking the natural movements of human fingers, something that no Tesla competitor has been able to replicate until now. Currently, the Tesla Optimus is powered by the Tesla AI 4 chip, the same chip used in the company's autonomous driving system. This processor allows the robot to analyze its environment and interact intelligently. However, when the commercial version is launched, it is expected to be equipped with the new Tesla AI 5 chip, which will go into production soon, making the Optimus even more powerful and efficient. With the arrival of this new processor later this year, the Tesla Optimus will take a significant leap in its capabilities, expanding its range of functions. From industrial tasks and domestic assistance to disaster rescue missions, the robot is being designed to operate in scenarios where human work is dangerous, repetitive, or exhausting. What was once just a futuristic concept is now moving towards mass production. Elon Musk has revealed that Tesla plans to produce thousands of Optimus units by 2025, starting with internal testing in its own factories. The plan is to ramp up production quickly, with the goal of reaching between 50,000 and 100,000 units by 2026 and potentially 500,000 robots in the following 3 years. When it comes to the adoption of humanoid robots, price is a deciding factor, second only to curiosity about their capabilities. Currently, the average cost of a robot of this type ranges between $80,000 and $300,000, a price that is too high for many people. This high price is due to the complexity of the design and the advanced technologies involved. However, companies like Tesla and Unitree are looking to change this scenario by making humanoid robots more accessible. To avoid the Optimus becoming prohibitively expensive, Musk said the goal is to keep it around $20,000. This price would put Tesla's robot in a highly competitive position. For comparison, the Unitree G1 costs approximately $166,000, while the premium model, the Unitree H1, starts at $90,000. With this price difference, many companies and even consumers could consider purchasing the Optimus without major concerns about cost. What makes the Optimus significantly more affordable than its competitors is Tesla's vertical integration strategy. The company manufactures its own motors, batteries, and transmissions, eliminating intermediaries and reducing costs in the supply chain. In addition, by reusing technologies already developed for its electric vehicles and applying the large-scale production model of the gigafactories, Tesla is able to drastically reduce manufacturing costs. Meanwhile, Unitree reduced the price of the G1 by optimizing its design. Its more compact form factor and simplified structure allowed for the use of smaller motors and fewer components compared to the H1 model. Despite these differences, both models have a similar weight. Another factor that contributed to the savings was the reduction in the number of wires, chips, and screws in the construction of the robot, which facilitated the assembly process and helped to contain costs. Another advantage of Unitree is the internal development of most of its hardware components, with the exception of the chips. This control over design and manufacturing improves performance and keeps the price competitive. The G1, with an estimated price of $116,000, is positioned as one of the most affordable options on the market. This feat stands out even more when compared to models such as the Atlas from Boston Dynamics, which exceeds $200,000, and the Spot robot, which costs around $74,000. It is worth remembering that these values are estimates and may vary as the robots approach the commercial phase. In the case of Optimus, there is speculation that its final price may be even lower than $20,000, consolidating its position as the most affordable and viable alternative for various applications. The final price of the Unitree G1 could end up being over $116,000, but it is still uncertain how these values will be adjusted in the market. Ultimately, only time will tell how much these robots will really cost. Elon Musk has high hopes for the Tesla Optimus, especially when it comes to its ability to learn autonomously in simulated environments. This method allows the robot to develop skills and adapt before it is even tested in the real world. This innovative approach significantly accelerates its learning, making it more independent. Thanks to this rapid adaptation, Optimus can adjust its movements instantly without relying on constant monitoring. Whether assembling batteries on a production line, handling household appliances, folding clothes, or even making coffee, the robot refines its movements based on previous experiences, just as humans hone their skills through practice. While some descriptions exaggerate by suggesting that Optimus is fully autonomous, the reality is that it still requires initial human intervention to set up tasks. However, once the necessary adjustments are made, it can operate almost independently, reducing the need for human supervision by around 99%. Its neural processor is impressive, capable of performing an incredible 144 trillion operations per second. This enables advanced object recognition and real-time decision-making. Additionally, Optimus's AI models are updated every 48 hours, ensuring that it is always learning and improving based on the latest data. For comparison, while many people pay around $20 per month for faster responses and frequent updates on tools like ChatGPT, Optimus already comes with a built-in system that updates itself automatically, without the need for external intervention. Musk's goal with Optimus is to create a truly self-sufficient robot that doesn't require frequent maintenance or worries about manual updates. Unlike many other humanoid robots that still rely on remote commands, Optimus is designed to manage its own functions. Its purpose is not to add more tasks for users, but rather to simplify their daily routines. One of the most notable advances is in its hands, which are now capable of performing extremely delicate tasks, such as cooking, shoveling snow from sidewalks, and even bathing a child, according to Musk. The third-generation Tesla Optimus features advanced tactile sensors that automatically adjust pressure and grip to suit the needs of each activity. The idea of having a functional robotic assistant, like a real-life R2-D2 or C-3PO, that never gets tired or complains, is becoming increasingly tangible. Optimus is able to process information and respond naturally to its environment, whether at home or at work. This capability represents one of the most anticipated milestones in modern robotics. In recent months, the way Optimus walks has been the subject of much debate. Many modern humanoid robots have peculiar gait patterns, which have led to amusing comparisons, with some people joking that they walk as if they've had a few glasses of wine. However, these criticisms often ignore the complexity involved in engineering these devices. While its walking pace may seem slow at first glance for certain functions, the reality is that its current speed, about 1 meter per second, equivalent to approximately 2.2 miles per hour, is sufficient for most tasks planned for this stage of development. It is worth noting that Optimus capabilities have not yet reached their final performance. Tesla intends to increase its speed to up to 2.2 meters per second, about 5 miles per hour, when it is commercially launched. Since late last year, the company has focused on improving both the robot's mobility and dexterity. According to Milan Kovac, lead engineer for the Tesla Bot project, the team is working on several key improvements, including integrating a more advanced vision system for improved planning, tweaking the locomotion to make it more natural on uneven terrain, increasing sensitivity for quicker responses to speed and direction commands, and developing techniques that allow the robot to fall safely and get up easily. These improvements are intended to make Optimus not only more agile, but also more versatile and reliable for real-world use. In one of the most recent demonstrations, the robot was put through its paces on uneven terrain, which generated mixed reactions. Initially, many joked about its unstable gait, and we admit we found it curious too. However, upon closer inspection, we noticed details that Tesla had not yet officially revealed. One of the most common questions was, why does an Optimus walk completely upright like a human? Why does it seem to keep its knees bent and move with a certain caution? These questions led some to doubt the viability of the project and even suggest that Tesla should focus exclusively on producing electric vehicles. We confess that, at first, we had these uncertainties too. However, as Tesla's updates progressed and Optimus was tested again, our perspective changed completely. In a recent video, the robot was seen climbing a slippery, uneven ramp, demonstrating two key points: its ability to adapt to the terrain and the way it adjusts its movements to maintain its balance. According to Tesla, this was Optimus' first test in such a challenging environment, a type of terrain that even humans approach with caution. Milan Kovac, the project's chief engineer, admitted that he nearly slipped while testing the area where the robot was placed. So it's only natural that Optimus seemed a little unstable. What was really impressive was the fact that it managed to climb up and down the surface without falling, especially considering that many other humanoid robots are not very good at handling uneven terrain. In addition to its mobility, another key factor in Optimus development was its safety. Like any electronic device, it must meet rigorous standards, and in the case of advanced robots, these requirements are even higher. Tesla has been clear that its goal is not only to build a highly functional robot, but also to ensure that it operates safely, respecting the privacy and protecting the data of its users. The Tesla Optimus Gen 3 comes equipped with a series of safety-oriented features, including emergency stop mechanisms, sensors to avoid obstacles, and an intelligent navigation system that allows it to operate safely in different environments, whether in homes, offices, factories, or busy places. These measures are designed to minimize risks and ensure that the robot can interact with humans without posing any danger. Other companies are also investing heavily in safety, but with different approaches. Boston Dynamics, for example, develops models such as Atlas and Spot, equipped with advanced sensors and sophisticated artificial intelligence for autonomous navigation. However, the company's priority seems to be more focused on the performance and versatility of its robots, while Tesla places a greater focus on safety and the end-user experience. Unitree, responsible for the Go 1 and Go 2 robots, incorporates basic safety protocols, such as obstacle detection, but its models do not have the more advanced protection systems found in the Optimus, which may be a point of concern for those who prioritize reliability and safety. Tesla already has a solid track record when it comes to data protection and privacy, something evident in its electric vehicles and digital services. Optimus Gen 3 is also expected to adopt advanced encryption, secure communication protocols, and access control systems to prevent any risk of hacking or misuse of information. In an increasingly connected world, this concern for digital security is more relevant than ever. On the other hand, while Boston Dynamics stands out for the performance of its robots, data protection does not seem to be one of its main focuses, since its products are mainly aimed at industries and commercial environments where privacy may not be a priority. Likewise, Unitree provides little information about its digital security practices, which may raise questions among users more concerned about protecting their data. Another important differentiator of Tesla is the strict control over who can access and operate Optimus. The company intends to implement robust authentication and authorization systems, ensuring that only verified users can command the robot remotely. This drastically reduces the risk of unauthorized access that could compromise user safety. For comparison, some Boston Dynamics models, including those used for military applications, offer greater flexibility in remote control, which can pose an additional risk. Unitree's more affordable models, on the other hand, may require compromises in terms of digital security, something that should be considered by more privacy-conscious consumers. Even though they are relatively close in price, the Unitree G1 costs around $116,000, just $4,000 less than the Optimus. There is a significant difference in reliability and safety. Tesla has been transparent about its commitment to ethical development of artificial intelligence, implementing safeguards to prevent misuse of the Optimus. In contrast, competitors such as Boston Dynamics and Unitree have not made similar statements about the ethical principles behind the development of their robots. Tesla's big goal with Optimus goes beyond simply creating a functional robot. It's about ensuring that it's safe, affordable, and capable of operating without compromising the privacy or security of its users.